All right, this problem, you got this expression, you're trying to rewrite it as the cosine of pi over something and then figure out what that's equal to. Um, Albert, the mistake you're making is a classic, absolutely classic mistake. And that is confusing what's being put into the trig functions and what's coming out of the trig functions. When I see you take this thing and say, okay, what I want to do is I want to do 3 pi over 7 times 2 pi over 21, and then add to that 3 pi over 7 times 2 pi over 21, that you're completely ignoring the fact that there's cosines here. We don't want to multiply the angles together, and that's what you're doing here. You're multiplying those two angles together. We want to multiply the cosines of those angles together, and then add the sines of those angles. I mean, as it is here, this product is going to be the same as that product, but it's not at all what we're after. You need to take the cosines, okay? So I'm going to do this problem two different ways. So this is just not, no, no. Don't multiply the inputs to those cosines. Multiply the output from the cosines, the ratio of sides. So when I grab my calculator here and I say, what's the cosine of 3 pi over 7? So I'll make sure I'm in radian mode. I am. So I'm going to type into my calculator cosine of 3 pi divided by 7. I get, so this right here is 0.22252 something, right? That's the 3 pi over 7 is not this, right? Because if I do 3 pi divided by 7, 3 pi divided by 7 is 1.3 something. The cosine of that 1.3 something is 0.22252, right? The cosine of 2 pi over 21, cosine of 2 pi divided by 21 is equal to 0.95557, right? So I figured out what 2 pi over 21 is, and I took that and I plugged it into the cosine and got this out. Likewise over here now, I want the sine of 3 pi over 7, which is 0.9749. I hate to round up more than rounding down. 7, 9, there we go. I don't have to round. And then the sine of that one, sine of 2 pi over 21, let me see, is 0.294755. So what I want to do is I want to multiply all those things. So I multiply these two together, multiply those together, and then add, right? So I'm not multiplying the angles, I'm multiplying the cosines of the angles, I'm multiplying the sines of the angles. And in fact, on my calculator, I would just do this all in one shot without writing down the intermediate steps, because I don't want to round if I don't have to. So technically, really, I would just type this in: cosine of 3 pi divided by 7 times the cosine of 2 pi divided by 21 plus the sine of 3 pi divided by 7 times the sine of 2 pi divided by 21. Let's see, cosine, cosine, sine, sine, go. And I get an answer of 0.5, which actually tells me what this one is. B over 2 is 0.5. This is equal to a half, right? So the B is equal to 1 here. At the same time, this is equal to the cosine of some angle, some pi over A. Well, I can use an inverse cosine now of 0.5, and I get that pi over A is 1.047 whatever. So solving for a, I want pi divided by, so a is pi divided by this number. And I'm not going to round, I'm going to just use the, I'm going to say pi divided by the answer, and it gives me 3. That is, this angle, maybe I should have known that, I probably should have, the angle is pi divided by 3. Right? Cosine of pi divided by 3 is a half. Pi divided by 3 is the same as a 60-degree angle. The cosine is a half. 1, 2, square root of 3 triangle for that 30, 60, 90. Okay, so this is, I think, actually not the best way to do this problem, but it is a way to do this problem that actually goes on, you know, did you wanted to actually figure stuff out and multiply them together and add them up? Well, don't multiply the angles together, multiply the cosines of the angles together, multiply the sines of the angles together. Okay. Now, really, the way that that this problem is, you know, the way it's designed to be done. Let me see if I can do this. So let's do this again a different way. And this is noticing that, hey, it's the same angle, 3 pi over 7 here, 3 pi over 7 there, 2 pi over 21, 2 pi over 21. This looks like an identity. This looks like a cosine. If this is cosine A cosine B plus sine A sine B, then I'm looking, oh sorry, A's and B's I'm already using, blah, blah, blah. So let's do cosine U cosine V, sine U sine V. So this should be the cosine of U minus V. So in particular here, this should be the cosine of 3 pi over 7 minus 2 pi over 21, right? U minus V, so this one minus that one. And that's what this identity is saying, that if you subtract the two angles and then take the cosine, that's the same thing as taking the cosine of each angle and multiplying those results, taking the sine of each angle, multiplying those results, and then adding those two things together. It's the same thing. So rather than doing this, I'm just going to do this. Well, I can get a common denominator. This is now the cosine of, I'm going to multiply top and bottom by 3 here. So 9 pi over 21 minus 2 pi over 21, which is the cosine of 7 pi over 21. But the 7 and 21 cancel, leave a 3, which is just the cosine of pi over 3. And so there we are. Cosine of pi over a, so a is 3, and we can figure out that the cosine of pi over 3 is a half, which would be 1 over 2, so b is 1. Anyway, this is so amazingly common a mistake that I've seen 1,000 times. I was going to say 1,000,000, but that would be exaggerating, and I don't think 1,000 is exaggerating. That people get confused about what's going in and what's coming out, right? The angle 3 pi over 7 is going into the cosine. The 0.22252 is coming out of the cosine, and that's what's being multiplied by this next thing, right? The point. So keep real clear in your own mind what's the angle being plugged in, what's the ratios of sides that's coming out of the trig functions. Okay. Anyway, there's that one.